Hello and welcome to another video. In this video we're going to be working on delete node in a linked list. And in this one you have a linked list and you want to delete a node and you're given the node but you're not given the head of the list. That's what makes it kind of tricky. And all the values are unique and it's guaranteed the node is not the tail of the list. So delete the node, it just means that the value should not exist and the number of nodes in the linked list should decrease by 1 and so on and so on. So essentially in this example, you basically just want to delete the node, so you want to make it look like this. And you're not given the head, so you're not given like this head, you're just given the node, but it needs to look like this. And the second example is like this. So basically, the tricky thing about this is like normally for a linked list, to like what do you need to delete a list? So let's just draw like a linked list. I wonder if there's actually one here. No, I don't think so. Yeah, so let's just draw a linked list, I guess. So we'll just have like a few nodes. Maybe like 4. Okay. And let's say we have, they're connected. So actually, let's just use this arrow thingy. So connect, another one like this. And let's say I want to delete this node right here. So I'm not going to focus on values. What do you have to do? So it's pretty simple. All you have to do is you just have to make the node before this node point to the one after. So instead of this pointing here, you just need this to point like this. And then even though this node points to it too, because nothing points to this node here, it will basically be deleted from memory. So you don't need to like worry about changing this. All you have to do is just make the node before the node point to the one after. But the problem is, like, let's say we're trying to delete this node here or something. So, all right, let's add in one more node. Let's add a node over here, like this. Let's say we're trying to delete this node over here with value, whatever, 5. So if we had access to the one before it, it would be pretty easy because we could just say, okay, that node's next can just point over here. And then that node's deleted. But we don't have access to the node before it, so we can't do that. So we have to figure out a way how to delete it without doing that. So let's say these values are like this. We can't delete this, like we can't just like make this next pointer point over here, but we can kind of do like a trick. And first I'll talk about just like a loop solution, and then I'll talk about a the trick. So a loop solution is basically like we can't delete this node, but what we can do is we can kind of like move values around. So there's a few ways of doing this. One way is like you can just traverse from here to the end and get all the values in an array. So you would just get all the values. So you'd say like, okay, well I have like 5, 4, 3, 2 in an array, and then traverse again and say like, okay, well I want all the values, but I don't want this 5. So actually, I guess you would get all the values after this node in an array. So you would get 4, 3, 2. And then you would just put them into the nodes. So you'd say like, okay, I'm on this node. Let's put in the first value. So I'll put in a 4. And then I'm on the second node, so I'll put in a 3. And then I'm on the last one, so I'll put in a 2. So you would just like do another traversal. And then once you're here, you put in a 2 and you're like, okay, I have no more values to put in. Then you can just say, okay, whatever node I'm on, let's just make its next point to null. So we'll just get rid of this. So that's essentially the same as deleting the node. So that's one way to do it, and that would work. Another way to do it is to use multiple pointers and kind of do a similar thing. So we have the pointer for our node, and then we have a pointer for our previous node. So even though this node exists, we don't have access to it, so let's pretend this is null. And then we have a pointer for the next node. And we can kind of do the same thing. So we could say like, while the next node exists, let's take our current node, have the value of the next node. So this node will get a 4. And then let's just move all of these nodes up. So we'll say like next moves up, current moves up, and previous moves up. Obviously you have to move them in the right order, but essentially it's like that. Then same thing again. So we'll just say, okay, for our current node, let's get the value of the next node. So we're going to delete this 4, add a 3, and then move them all up again. Like this. And same thing, so let's take our current node and give it the value of the next node. So we'll give it a 2, move all of them up. And then once your next node is null, that's when you just say, okay, my current node now is on the last node in the list. This is actually the one I want to delete. So you can just say, okay, I have the previous node. Now I can make its next pointer equal to null. So I can just get rid of this connection and I will get it like this. So this is another way with 2 pointers, or with 3 pointers, I guess. Maybe you could do it 2. You just traverse and you just move values around. There's actually like a shortcut way to do all of this. And basically, because our node is not in the tail, I think if it actually was in the tail, it would be impossible to delete. And there would be like no value you could use to replace it with. Like if they were trying to delete this node here, I guess it's 2. If this is the node we're trying to delete, we can't because we don't have access to its previous node and we can't just like copy values in. So if our node's in the tail, this would never be allowed to be deleted. But because our node's not in the tail, we can actually do like a shortcut here. And all we have to do, if you think about it, so we don't have like, we can't just delete the node itself, but we want to delete this value. And so what we can actually do is we can just say, okay, let's just make this node's value equal to its next node's value. And instead of doing that whole thing where I had like these 3 pointers or array, now that I have that, if you actually look at it, we wanted 432 in the end, and we have 4432. So because we took, like, we basically got rid of our current node's value and just made it the node after it. Now all we have to do is delete this node, and then we still have the 432. So it's pretty easy. So all you do is you just take your current node and you say, okay, my node's value is equal to the next node's value. And that would give you a 4 here. And then you say, okay, well now I can get rid of this node because I have access to this node. So now I can say this node's next pointer will be equal to its next node's next pointer. So it'll be equal over here. And that would effectively delete this node. So that's kind of like the trick. I don't know if it's like super easy to figure out, but also, like I said, an array or a whole traversal and just getting rid of a bunch of nodes works. But this is kind of like the trick is all we have to do is just replace this node's value with any, well actually it wouldn't be any, it would have to be the node after it, and then we just delete the node after it, and that basically avoids the loop. So we can have an O1 solution like that. And so that's the one we can code up, and it's super easy. So we can just say node val equals node next val. And because this can't be the tail, there will always be a node next. Then we'll just say node next equals node next next. So essentially, this node's next pointer is just this node's next pointer, which is just the node that's 2 nodes after it. So it'll be over here. And we get rid of this, and this node effectively gets deleted. And this will give us our 432, same thing. So this is all you need. Hopefully it makes sense how I got that from like doing all of the solutions, how the shortcut works. Yeah. And so this is obviously pretty easy. So time of 1 and space of 1. But I would say if you are doing linked list problems, I would still try to code this up using the like either the array or the 3-pointer, because it gives you a lot of practice traversing linked lists. So I would still recommend doing those, but just know that you can do it this way too. Because for most linked list problems, obviously it's not going to be like 2 lines of code. So, but in this one it is. And yeah, it's going to be all for this one. Hopefully it's helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.